pressure of left atrium. So left atrium contracts just before the ventricle. Before the ventricle contracting here, so left atrium here. Then atrioventicular delay here, and then contraction of left atrium, of left ventricle. What happens if the pressure, when left atrium is contracting? Pressure in left atrium here would be increased, slightly increased, to up to 10 plus 10 millimeters of the mercury in left atrium. But what happens then? Then we have contraction of the ventricles. What happens during contraction of the ventricles? If you look at your first experiment where you register mechanocardiograph of the heart which was removed from pericardium, we will see such contractions. Ventricle small during contraction, ventricle large, atriums large during diastolic period. So we see that heart decreases and increases its external size while registering mechanocardiograph in the experiment if heart is dissected from the pericardium. But this situation in thorax, in normal function of the heart, is completely another. In the thorax, heart is integrated into the pericardium, which contains two layers. One first layer, external, is tightly connected with mediastinal organs, the other connected with heart. Between them, no air, space, without any possibility of changing its size, pericardial space. This pericardial space makes impossible the change of external size of the heart. So external size of the heart during systolic and diastolic period being constant. It's caused by pericardial space, which is fixing this external size of the heart. What happens then? While contraction of the ventricles, they should decrease their size. If there would be no decrease, then no cardiac output, of course. So they decrease their size. They decrease their size while contracting only due to this shift of the wall, atrioventricular wall. This wall is shifting to the apex, is moving to the apex, ventricles decreasing their size, but overall external size being constant. That means that atria should be stretched, dilated. And this dilation of the atria decreases the pressure inside the atria. As far as the ventricle being contracted, enlarged size of the atria and increase in the pressure of the atria. Pressure in the atria drops down below zero. We have here the pressure in the atria being negative. And this negative pressure in the atria suckles the blood from veins into the atria. This important factor of venous return to heart, where there are no additional forces of blood movement in veins. Main factor of venous return to heart is the suckling effect of the heart during phase of ventricular contraction. This negative pressure in atria suckles the blood from veins and being neutralized, and then zero, again the pressure zero, up to next contraction of the ventricles of the atria, when it would be slightly positive due to contraction of the atria, and then again negative and again zero. So this curve, this line shows the pressure in the left atria. Important feature of this pressure is that there is suckling effect of the heart during ventricle contraction. During ventricle contraction. That's one of the most important factors of venous return, which you will discuss later on the lesson when we will be discussing blood circulation. First, venous return factor of venous return is suckling effect of the heart, shown here. So remember this effect. So now write the experiments, continue writing the experiments, and then